My internet connection is not stable today. So give me a moment. I'll share my screen again. Mhm. Yeah, my internet connection is not well today. So the question was, suppose you have a raw text corpus and you compute word co-occurrence matrix from there. Yeah. Which of those algorithm can you utilize to learn word representation? So the options are CBOW, SVM, PCA, and bagging. Okay. So so we know that first one is CBOW. So what is the purpose of this? So CBOW means continuous bag of words. Okay. So this means continuous bag of words. Okay. So so this is a part of word to vec model. Okay. Word to vec. So this is a part of word to vec model, and this learns the embeddings, but it typically uses a sliding. You know that Fibao counts the continuous backup words, counts the positive and negative words. So it typically uses a sliding window rather than a direct co-occurrence matrices. Okay, so co-occurrence matrices can still be useful for training word embeddings in related models like Globe. Okay. So CBOW is the correct answer, that we can use CBOW algorithm to learn the word representations. Another one is SVM, so support vector machine. The support vector machine is a classifier kind of model to classify between two data points. Okay, so this is SVM. Okay, so this is called support vectors. There are two support vectors. So this is called the SVM. So this used for classification algorithm, and this is not directly used to learn word representation. And PCA is the dimensionality reduction algorithm, principal component analysis. So you can compute the PCA using the single value decomposition or eigenvalue decomposition. Okay, so PCA can be used to reduce the dimensionality of the word co-occurrence matrix, while it also preserves the important variance. So which effectively in effectively learning lower dimensional word representation. So PCA can be used here. And bagging, I think bagging is the ensemble learning method used to improve model robustness, and it is not used for learning word embeddings. Okay, so CBOW and bagging are the answer. Fine. Now, so this one is the second one. So can you please try this one? Okay. So this question is about what is the method for solving word analogy question, like given A B D, find C such that A such that B, like A such that B, that implies C such that D using word vectors. Okay. So can you write your opinion in the chat box? Uh, so we have to find the method for solving what method for solving word analogy using word vector. Okay. So in word analogy tasks, we are given four words. So four words are A, B, C, and D. Where we need to find C. We have to find C such that the relation between A and B is similar to the relation between C and D. So this is written like A such that B. That means that relation between A and B is similar to the relation between C and D. This one. Okay. So this is the analogy representation. So this represent the analogy relationship. Fine. Now, using word vector, we represent each word as a vector using word embedding like word to vec or globe. The core idea behind solving word analogy question is based on the vector arithmetic. Okay, so you can find out the cosine similarity or any other kind of similarity. So in details in today's lecture, there is a description of this similarity. How you can find out the similar. Sorry, I was muted. Okay, so in detail, in today's class, it was described that how you can find out the what is a co-occurrence matrix and how can you find out the vector similarities. Okay, so maybe you can find out the cosine similarity, or there are also other things. So we'll see that what are the others. So there are like what frequency, document length, and document frequency are there. Okay, so you can find out the weight or point-wise mutual information. So these are the ways. So now here you have to find out. Yeah. So you have to find out that. So you have to find out that using word vector. So which is the method for solving word analogy question? Okay. So that fundamental assumption is that what do we want to do? So what is the approach using word vectors? So we represent each word as a vector using the word to vec. The core idea behind solving word analogy question is based on the vector arithmetic in embedding space. Okay. The fundamental assumption is that the relationship between word pairs can be captured as a linear transformation in a vector space. The goal is to find C such that this one p minus a. Okay, so this relationship between the word pairs can be captured as a linear transformation in the vector space. Okay, so if we rearrange, we have to find C. If we rearrange, we have to find C. That means D vector plus A vector minus B vector. Okay. So once we compute the C vector, we need to find most similar word to C vector. So this is done using the cosine similarity, which cosine similarity measures how close the computed vector is to the actual word vector in the vocabulary. Okay, fine. So then what we have to do? So first option is this one. So first option is VC is equal to VA plus VB minus VD. So I have shown to here. So which option you think is the correct one? Okay. So this one, the option C is the correct one. VC is equal to VD from here. Okay. Then use cosine similarity to find the closest word of VC. Right. So this is the correct one. Okay? Yeah. So yeah, just give me a minute. I'll come back to that. Yeah. So Vaishali has asked that, sir, how can TCA be answered? The first question. Yeah, I'll come back to that. So to answer our this one, you can try to answer this one. So this question is on that point-wise mutual information theory and calculation. Okay. So so basically this question is asked. This question asks that what is the value of PMI? So PMI is the point-wise mutual information. Okay, for CW1 where CW count of W1 is 250 and count of W2 is 1000. Now count of W1 and W2 is 160. N is equal to 1 lakh and N is the total number of document. Okay, CWI is the number of document WI has appeared in. So this CWI counts the number of documents WI has appeared in. Okay, and this says the number of documents where both the words have appeared in. So use base 2 in logarithm. Yeah. So what is the formula? So what is the PMI? What is PMI? So PMI is point-wise mutual information. Okay. So this is a measure of association between two words in a text corpus. Okay. So what did it calculate? Okay, in a text corpus. So it quantifies how much more or how much less likely two word W1 and W2 are to appear together than they were independent. Okay. That means we calculate it by PMI W1 W2 using the formula log. Here we have given that use base 2. So we'll be using base 2 P of W1 comma W2 by P of W1 P of W2. Okay. So this is the PW1 W2. So this is the joint probability of both words appearing together. Fine. And PW1 and PW2 is are the individual probabilities of each word. Fine. Now we have to calculate. Now here we have so in terms of document count. So we have here we were considering the count of the probability of words. So but we have to uh, take in account the number of documents also. Then the formula will become this one. So this is CW1 and CW1 W2, which is nothing but number of documents containing both W1 and W2. Okay, fine. This means number of documents containing both W1 and W2. Okay. So if I do this like so, this is basically so I have to so the formula for PMI is this one. Here I have to find out the probability. So how can you find out the probability? You can find out the count by total number of documents. So same count of W1 in total number of documents. Count of W2 in total number of documents. So this formula will become this n and this n will this n and this n will cancel out. Then the formula will become this n will go up here, then CW1 and CW2. Right? So this is the formula. Hmm? So if you so this is given that CW1 and W2 is 160, 1 lakh, 250. This is given. So how will you calculate? You calculate by 1 Sorry, 1 lakh by 250 into 1000. I'm just putting the values on it. So it become log to 64. So which is nothing but 6. 2 to the power 6 is 64. So what is the correct answer? Which is the correct answer? Correct answer is C, 6. Friend, is it clear to you? Okay. Okay. Now come back to this one. That it is this question that suppose you have a raw text corpus. So you have a text corpus and you compute word co-occurrence matrix from there. So what is this co-occurrence matrix? So count number of times the so basically what is the informal algorithm for constructing word spaces? So you have three things. One is target word. The target word is that pick the word you are interested in. Then you define a context word. Okay. So context word is number of words surrounding the target word. Okay. The context can in general be defined or in terms of document, paragraph, or sentences. So whatever. So I eat curry with the rice. So if curry is my target word, then rice and eat are the context word. Okay. Then then count number of times the target word co-occurred with the context word. Okay, so this is called the co-occurrence matrix. Right? What does it mean? Count number of time the target word co-occurs with the context word. Okay. And now, this happens that yeah. So this is clear. Okay. So now from here you have to build vectors out of a function of these co-occurrence counts. Okay. So from here you find the distributional semantics or the distributional matrix, which is nothing but target cross counts. So our answer is that so our question was you have the raw text corpus and you compute word co-occurrence matrix from there. Which of the following algorithm you can utilize to learn word representation? Okay, so how can you represent a word from this co-occurrence matrices? So PCA is the mathematical technique used for dimensionality reduction. So it basically decomposes a matrix. So if you have given so you got the point. What I am trying to say, this co-occurrence matrix is a matrix, okay, which is of size target cross context. Okay. Now, as this is a matrix, you can apply SVD here, singular value decomposition, okay, or eigenvalue decomposition. Then you will get two matrix like this, okay, two three matrix like this, okay. So this is the singular value decomposition. From here, so basically PCA find a set of orthogonal axis or principal component that best capture the variance in the data. So it applied to a word co-occurrence matrix, and PCA can generate lower dimensional word embedding. Okay. Now, so basically first you are constructing the word co-occurrence matrix. Okay. The matrix can be transformed using pointwise mutual information to improve the quality of the learned representation. Then you are applying PCA to reduce the dimension. PCA finds the principal component that retains the maximum variance in the data. each word is projected onto a lower dimensional space where word with similar meaning remain closer in the new representation. The resulting embedding captures semantic similarities. Okay. Now, how you will generate the word embeddings? The top D principal component where D is the embedding size is selected as a new feature. Fine. Each word representation has a d-dimensional vector, similar to how word2vec and globe can create embeddings. Okay, I think this is clear. So first you have to first consider a word co-occurrence matrix for for some word. Okay, then you can apply the PCA to stack the pattern such as gender differences in king and queen or category relationship, how king and man is together and queen and woman are together. Okay, after PCA your embedding will the PCA will capture the important dimension. Okay, so this PCA will work for the word representation. You can try this one. first one. So given to binary compute time, and the second question consider similarity score with TL divergence. Okay. So first one is the given two word W1 and W2, compute the dice and checker similarity between them. So I think this is a easy question. This is just the calculation you have to do. So I think this is the answer. So what is dice similarity? So dice similarity is another measure that gives more weight to the intersection by considering the average size of both sets. First comes the Jaccard similarity. Jaccard similarity measures the proportion of common one values intersection to the total unique one values. Okay. So it basically the formula is for Jaccard similarity. The formula is W1 W2 is equal to W1 intersection W2 by W1 union W2. Okay. And for dice similarity, W1 W2 is equal to 2 into W1 intersection W2 by mod of W1 plus mod of W2. Okay. So how we will identify similarities? So first we have W1 is equal to so it's like 1 0 1 0 1 0 1 0 1 0. Another one and W2 is 0 0 0 0 1 1 1 1 1 1 1 1 then 0 0. Okay. Now what is the intersection? What is the intersection? Intersection of W1 intersection W2 is equal to common one in both position in both vectors equal to 3. So basically we have common here position 3, position 5, position 7. Okay. Oh, sorry, I have it wrong. So this will be so these are 0 zeros. Okay, these are 0 zeros. Okay, so these are the position 3, 5, 7. Okay, so in together, so basically 3. Okay, fine. Now, if you see the union of W1 union W2, then you will get that total unique ones. How many unique ones are here total altogether? 8. 8. Okay, then total ones in W1 is equal to 5. Total ones in the W2 is equal to 6, right? So how will you find the similarity? So this is nothing but 3 by 8. So 3 by 8. Okay. So if you find out the formula, then for here 2 into 3 by 5 plus 6. So for dice similarity, the formula is 2 into W1 intersection W2. Okay. By W1 plus W2. Okay. So 2 into 3 by 5 plus 6. Okay. That is nothing but 6 by 11. Okay. So which one is the correct? 6 by 11 and 3 by 8. I think option A. Yeah, option A is the correct one. The next question is also a simpler one. Okay. You take your time and try to solve it. Please mention your answer in the chat box. Okay, so how to solve this one? So here we have the formula for the tail divergence. Okay, so you will be able to find out from here. So the correct answer is C. Okay, so in the next question you have to find out, consider the following word co-occurrence matrix given below. Compute the cosine similarity between W1, W2 and W1 and W3. Okay, so this is the matrix. And so you have to find out the cosine similarity. So what is the formula for cosine similarity between vector P and vector Q? It is nothing but P vector into Q vector and P vector, yeah, Q vector. Okay, so this is the formula. Okay, so the answer here is, so I wrote the formula here. So this is the solution of this question. So right answer is C. Okay, so you can find out the cosine similarity like this one. This one. Then okay. So this is the last question for today's class. Can you try to answer this one? So after answering this one, like you can feel free to drop off. Okay, thank you everyone for joining. We'll meet on next week.